GCSE error-bound questions will have keywords such as nearest and accuracy. They will say that something is measured to the nearest 10 or 100, or that it is given to an accuracy of two significant figures. We need to remember to plus or minus half the units. This will become apparent when we look at these examples. First of all, we've got 30 rounded to the nearest 10. So we plus or minus 5 to get our lower bound and upper bound of 25 and 35. To get written as an inequality, we can write 25 is less than or equal to 30, which is less than 35. Looking at the next example, we've got 5.3 kilograms, which is accurate to one decimal place. So we can plus or minus 0.05. So the lower bound, take that away from 5.3 to get 5.25 and add it on to 5.3 to get 5.35 as our upper bound. Again, this can be written as an inequality seen here, or you can write it on a little diagram. So you've got 5.3 is in between 5.2 and 5.4 decimal places. However, halfway between 5.2 and 5.3 lies our lower bound, which is 5.25. Halfway between 5.3 and 5.4 lies our upper bound, which is 5.35. We need to look at calculations as well. So if you take a moment to copy this down, we've got A plus B, greatest, we have maximum of A plus the maximum of B. To find the smallest possible, we take the two smallest and add those together. When taking away, we look at A maximum, take away B minimum. For the lowest, we have A minimum, take away B maximum. To get the greatest value we're multiplying, we take the two larger values and multiply those together. To get the lowest value, we take the two smaller values and multiply those together. When we divide, to get our greatest amount, we want the largest of A divided by the smallest of B. To get the lowest, we want the smallest of A divided by the largest of B. This can sometimes be easier to see as an example. So looking at this rectangle here, we've got 8 by 3. My upper and lower bounds are seen here. To find the smallest area, we want the two smaller values, and we multiply those together to have 18.75 as our answer. Take a look at this question. Pause the video and see if you can have a go. We've got a cable, 5,300 kilograms to the nearest 100, so that plus or minus 50, leaving a lower bound of 5,250 and an upper bound of 5,350. The crates are 100 kilograms to the nearest 10, so we plus or minus 5 with a lower bound of 95 and an upper bound of 105. The number of crates then we want is the greatest number. So we take the largest number divided by the smallest number to give us 56.316. The next one, have a look at this one, see if you can have a go. Pause the video. We've got a distance is 50 metres to one significant figure, so it's i.e. the nearest 10, so we plus or minus 5, giving us a lower bound of 45 and an upper bound of 55. Speed is metres per second, one significant figure, so we plus or minus 0.5. So a lower bound of 4.5 and an upper bound of 5.5. You need to remember your speed, distance, time triangle for this question. To find time is equal to distance divided by speed. We want the least possible, so we take the smallest lower bound there, divided by the upper bound of speed. So we've got 45 divided by 5.5, leaving us with an answer of 8.18 seconds.